Yes, we'll start the session. So, hi everyone. My name is Sagar Kakkala, and now here we are for a DevOps session. Like we will be in, I think, like this is day 11 in DevOps session, and with this, like we would be like finishing DevOps, uh, and we will be entering into DevSecOps from the next session. And here in Sagar Kakkala's world, like since I'm just doesn't do content only constrained to DevOps, there's a bit of like travel, finance, podcasts, and bit of other stuff. And so just to let you know how things work here, I'll just share screen to know how you could separate content. Could, you just have to remember my name and search in Google Sagar Kakkala, and you'll have my website, LinkedIn, and YouTube. And in YouTube, everything is separated by playlists, as you could see. If you want like DevOps with SK English is the one that we are going now. And since this session is Terraform and it's like individual from these sessions, it's not linked at all. But I would suggest like later, it's better if you watch it in a link to understand things better. And as well, there is a website as well as you could see. Mhm. The website is separated by contents of the blog. So everything in an order, in a consecutive order. And in the website, we have only DevOps and finance. Yes, with this, we'll go straight into the session. Okay, I think I don't think I get. Okay, fine. I did not get this. Fine. We will be using Terraform. So Terraform is actually widely popular because it can be used as infrastructure as code. What do I mean by infrastructure as code? It's because let's say we have in our infrastructure we have EC2 instance or S3 bucket or even RDS instance, whatever it is, you could actually bring that into Terraform control. So that is where like we get like with a bit of scripts like which we would be seeing further in the session. So that is where like Terraform is called as like infrastructure as code. And apart from yes. And apart from Terraform, even Ansible can also be used as infrastructure as code. Mm. But Ansible is mostly used, never used that much in infrastructure as code, though it can be used. Why? Because Ansible and Terraform make a difference only at one point. Like Terraform provides state files like Terraform state files. State files are nothing but the infrastructure at that particular point, which we will understand even like when we go into practice. And as well, like Terraform is widely popular because it can be used in multi clouds. Let's say you have an AWS environment and you have an Azure environment. Like there are some resources in AWS and there are some resources in Azure and or even GCP, whatever it may be. So you could use Terraform, like a single Terraform, to actually like provision the infrastructure in AWS or even Azure or even GCP, and it could support multi-cloud. Whereas just like Terraform, AWS has like cloud formation, and this cloud formation cannot be used to bring up the resources in Azure. And same way, Azure has ARM templates, like which cannot be used to bring up resources in AWS. But whereas Terraform has a like wide variety of plugins. Let's say like you have an AWS plugin, Azure plugins, and even GCP plugins. So it supports multi-cloud. That's where like Terraform is like widely popular for it, and it's widely used for infrastructure as code. And things are a bit easy when you use Terraform, like which we would see. Like we'll start with installation and we'll start up a resource and this thing. And yes, I'd give a bit of explanation of how things work inside an organization as well, like once the Terraform session would done to have a clear idea on this. Like we'll start directly with the installation of Terraform. Since this is a Mac OS, like I actually used, yes, before installing Terraform, I would also ask you to like download VS Studio Code and also an extension of HashiCorp Terraform. This is just for us because it formats syntax and everything. It would actually suggest if you have an HashiCorp Terraform extension, like what could be next. And as well, like this is a Terraform download page. So this is a Mac OS that I'm using. So I'll be using these commands to install Mac. And also once it's installed, I had to like because I had to work with the terminal everywhere. So I would be updating the path as well and to restart the shell path because Mac and like Linux work the same way. And as well, this is for Windows actually. All the screenshots are for Windows. So you could even actually use it for Windows on where to update the path so that you could use Terraform commands everywhere. The same way. For Mac, I just gave a simple script here. I'll be just using this script now. Okay. Okay, I did not give the permission, so that is why it's not allowing me. Okay, got it. I'm just giving the execute permissions. Okay, Terraform installation is now completed. Now I'll be using Visual Studio Code. And just like if you see, if the Terraform command doesn't work, you just had to like reload, I mean like restart this, that's it. Restart Visual Studio Code for it to work since it's working. Yes, fine. Now the Terraform is installed. Now we want this to connect to our AWS. So to connect to this our AWS, like we would be creating an IAM user inside our AWS account. Let's say, okay, I think yes. One second. Second. 1 second. I see someone joined the group. Users and create user, and I'm just naming this Terraform. You don't need a console access. I'm attaching policies since it's a Terraform. I'm just giving admin access directly for it to create every resource it wants. And next, we'll just create user. And once the user is created, we'll go for security credentials because we want console access for a Terraform. You'll just create security credentials. Where are they? Yeah, access keys. So we'll be creating access keys and CLI. And next, just giving some random tag. Yeah, it's better to download a CSV file. Yes, we got the CSV file now. Now let's go for this file and I'm going to create a new folder for this, like for Terraform demo. Uh, Yes, I'm just creating a new file now because we want our Terraform to have access. So I'm just giving providers.tf, and always remember Terraform files must be end with an extension .tf. So providers.tf. Now to establish connection, I'm just going back. You need to have this access keys, IDs. Yes, where's the blog? Not the. Okay. Yes, the installation is done, and the IAM account we created, and the policies is done. Security credentials is done. Now we'll go for provide. Yeah, we created an empty folder. Yes, this is the one. So I'm just giving a providers for our Terraform to connect with AWS. Like this is what I'm doing. We are just giving a providers.tf file. And yeah, I don't know why. For Mac OS, this is actually a bit of issue. Some unknown characters were coming, and I don't know what they were. And here in this path, like in access key and secret key, this is the one like we would be giving in the credentials, like which we downloaded for our file. So this this is an access key, and for secret key, I think when it's created. Is this the one? One second, let me verify. AKIA, AKIA. Okay, fine. Yes, this is the one. And as well, like this is the region like which we want to provision our resources, Terraform resources. But since like we have the region, like we have a different region in which our EC2 is running. Let's say, I think this is IQ. One second, I think I missed it somewhere. Okay, this is the previous key. Sorry, my bad. Because there are two CSV files opened, I got confused. I'll just copy it from here. Yes. Now let's say I want to go for an EC2 instance where our EC2 is currently running. It runs in North California. Like North California is like US West one. So I'll just update our region, like in which we want our EC2 resources to be up or the Terraform resources to be up. So US West one. And once this is up, let's say like we want Terraform to get the plugins of AWS because we provided AWS, and for it to connect with AWS as well, we'll just give the command like Terraform init. Terraform init is nothing but like Terraform initialize. So it will get all the required plugins for our AWS. And you'll be able to see a new file here like .terraform. So this got the plugins. So we were able to connect with it, like we were able to get the plugins. Now to test, let's say we will test using AWS EC2 instance, and Terraform actually provides a documentation for everything. So I'm just going to give like Terraform AWS EC2 and Terraform registry. It's the documentation part where you could get like everything. Let's say this is a data is something like which you want to read the information which is already existing. Let's say what it does, like it goes for AWS AMI and it searches for Ubuntu and it gets this ID named with this filter. Like to read an existing data we use the data block, and resource block is something like which we want to turn up the resources like AWS S3 bucket or AWS EC2 instance or even AWS RDS, like based on what resources you want to make provision. So based on that, like these things would change. AWS instance or AWS S3 bucket or even AWS RDS, like you could check in the documentation itself, it will be available. And this would be the name which we would give to that particular resource. Let's say resource of this, but not our original resource that we'll provision. So we'll actually take this as well as an example. Let's say I'm just creating this main.tf, or even you see, okay, it created a wrong file. My bad. Let's give ec2.tf or let's main.tf. Anything with an extension of tf. So I'm giving this, I'm just changing this. It's like T2 micro, cause T2 micro is free tier. And web, it be, yeah, let me make it as default itself web. And hello world, I'm just changing it to something random. Now, once we initialize it, let's say you could actually initialize again for it to bring the resources of EC2. And if you are going to keep another resource of S3 bucket, like even that you need to initialize again. Like it's good when you like run the initial command as Terraform init so that we will not miss the plugins. And now, once it is done, and also one more thing I could actually show you here itself. Let's say these were actually not in a, let's say the code is not looking neat or something. This is another command that you could use for it to look neat. It's just Terraform format fmt. Okay, I think I gave no Terraform two times. Yes. So actually it fixed even the spaces and everything that I messed up. So Terraform format could be used to make the command look neat. And also now the real command starts, like it's Terraform plan. It actually shows like what resources would be up when you actually like run this. Yes, where is this? So okay, I did not save plan. Fine. So it actually shows me like what resources would be up, as you could see, AWS instance web. So this would be up, and like few things would be known after reply. And also one more thing that we could use here is like outputs.tf, and there are some things that I missed. Maybe I'll just go back to documentation again. Where is this? Yes. Here, as you could see, here AMI instance type, like these are called arguments. And if you want something, like once the resource is up and you want some data out of it, and that we call as attributes. Let's say here for like data AWS AMI Ubuntu dot ID, dot ID is an attribute here. Similar for data, this is an attribute, dot ID is an attribute. Similar way for this block, like AMI is an argument. And if you want to see like what arguments you could pass apart from AMI and instance type, you could just click on the same here. As you could see, AMI is an optional, this is optional, this is optional, and if it shows like required, without that, like your instance won't be up. If it is optional, like Terraform takes by default whatever value it has. And here you could see there are like attributes. So from this resource, we could actually, okay, fine. From this resource, we could actually get the attributes like, let's say, AWS instance.web.id, AWS instance.web.arn, or any information that's there in the attribute. So all these things that you could bring it out from that instance created, like in an output block. We would actually have the output block as well. Let's say, yes. Once the provider init, okay, this is the one that we did. Arguments, attributes. Okay, output I did not give the copy. Terraform format. Okay, yes, this is the outputs value. Fine. So I'm just taking like one output value here. You could take any value that you need. So just giving going back here. Okay, these are some characters that are getting in MacBook. I don't know why. Yeah, I'm just going again Terraform init. Okay, so now I'm just going to give Terraform apply. It actually asks for me whether I had these provisions are right or wrong to apply it. You could actually like to avoid that box, you could actually give also auto approve flag for that. Let's say it's creating an instance. And also now you could see it formed a state file now. It's a present infrastructure like which is there. So it's like with one EC2 instance, it has that state file. So it keeps that state file. And now let's say a new resource comes. And if you give like Terraform apply again, like this state files get updated. So what we do in organizations is like we save these state files in versioning. Let's say now I gave Terraform apply. It's a version 1 and now if I like bring up new EC2 instance or like new S3 buckets and we would be saving that as version 2 like in an S3 bucket all these state files would be saved. Let's say someone new joined and messed up like S3 bucket or something and we want something to be in the previous infrastructure state. So what we would do like instead of like the present Terraform if it runs in version 5 or something we would use this state file to get into version 4. It's more like a rollback of a complete infrastructure. So that's where like state files are important and these state files are something which Ansible fails to provide. That is why like Terraform is widely used. And also as you could see like Terraform lock, this Terraform actually has a state log as well. Let's say if there are like multiple people working on the same infrastructure. Let's say if I am like turning up EC2 instance and some of like someone like maybe my colleague is trying to delete the instance and the state files must not be like getting confused on like what to update like it's more you could compare it to like get merge conflicts, so it is more like that so that like when one person is working the state lock would be applied so that other does not make changes to the state. That's where even the state locking comes into picture. Okay, let's see if the REC2 instance is up or not now. Okay, where is REC2 instance? Yes, instances. As you could see, this is the one that we created just now. Yes, and if you want to destroy this, you don't have to manually delete this. And there is a command called like Terraform destroy, and this is the command, a very dangerous command, and not to specify, like not to use it anywhere. As I said, you could actually use auto approve as a flag, but never use with Terraform destroy flag. Since this is a demo, I was just showing that you don't need to enter that value S. So if you just give this, like whatever is in the control of Terraform, like exactly in this state file, it deletes everything. So as of now, we have only the EC2 instance in our control. So it actually deleted, as you could see, 0 to add, 0 to change, 1 to destroy. So it's actually destroying this instance. Mm, yes. Shutting down, terminating. Till here, everyone is clear, right?
Yes, sir.
Yeah, yes. So this is something when you had the new resources to be up in control. Like what if, let's say, there is a production instance and you can't stop or like restart production instance. Even in dev, it's not recommended. But what if there is a server which is already running and you want that to bring in Terraform control? That is where we would use Terraform import commands, which, yes, maybe for that, like we will launch an instance now. I'll just use the blog itself. Yes, this is done. Yes, let's say Terraform resource to import. Yes, let's say something. I'll just turn up an EC2 instance. Let's say this is not under Terraform control, and I'll be uh, manually provisioning. This is a free tier. I'm just giving some random key. Launch instance. I would say since it's a demo, just play with the free tiers itself. Do not go with high-end instances. Okay, now this is done. As you could see, Terraform import instance. This is running, but this is not under Terraform control. And I want this to be under Terraform control, like which is already running. For that to happen, I just need this instance ID. And also before that, I need to create a resource block for this instance. Let's say the resource block would be something like this. As I said, like this could be any name for this resource name. This is actually the resource name for Terraform to identify, not our AWS resource name. So let's go for this. I think this is not needed. Let me close this. Yeah, delete. Okay, now let's see. I'm just creating a here. Hmm. I'm just giving Terraform init again. So once this is done, now going back to my blog, I'm just saving this ID, and this is where like Terraform instance is used. I mean, like to import command is used. This is what are we importing? We are importing inside AWS instance dot Terraform import dot instance. So we will be importing inside this. So, but this is not the instance ID. This is the one in the demo. Let's actually get the new instance ID. The new instance ID would be, where is this? Yes, this is the one, the new instance ID. Yes, it's importing. As you could see, the import is successful. But here, only thing, like only drawback with this import command is we had to fill these things manually so that like Terraform will have it under complete control. Let's say now if I want to have this under complete control, what I want to do, I want to fill these information, but I don't have this information and I don't want to check inside the AWS console. So what I could do, I could use, because everything is saved inside like state files, I could actually use Terraform state command shows like this, like Terraform state show. So this would get our complete info of what we needed. As you could see, it got the information that whatever the instance had the information, it got the information. So I'm just having this, and the T2 micro and the AMI ID would be this. And the name is actually different. I don't name do we have? We will have it here. Mm, Metadata, where is the name? Fine, I'll take it from directly from the console itself. Now I'm giving Terraform plan because we had this instance already. Even this instance would be up. If you don't want this instance to be up, you could just remove these lines or comment out these lines so that it will not, I mean, like from here to here, so that it will not get into Terraform. Let's say I'm just giving this, I'm just commenting out for time being. I'm giving Terraform init because this instance is not there and this instance is already up. So Terraform has no work to do here. So let's say I'm just giving Terraform plan now because this resource is already up. Okay. Oh, yes, outputs.tf has this, right? Okay. Because AWS instance web is not there. So that is where it's failing. I'll comment out this as well. And how Terraform plan works is it compares the AWS state, let's say the infrastructure, whatever state is there, and our code, and it sees whether it has to provision new resource or not. So as you could see, it has nothing to do. So that is why it said like there is no change at all. Now to know whether it is under Terraform control or not, I'm just gonna give like Terraform destroy. Let's see, our resource is up now. So I'm just giving Terraform destroy to let you guys know that it is under Terraform control now, though we had manually provisioned the resource. It even asks like what to be deleted, and these are the resources that would be deleted. And as you could see, one zero to add, zero to change, and one to destroy. Mm. Okay, it's destroying. Meanwhile, I'll just uncomment these things. Okay, it's still destroying. Oh, my bad. As you could see, both it got terminated. So till here, everyone is clear, right? We will go for modules now.
Yes, sir.
Yes, yes. Yes, thank you. And now we'll go for Terraform modules. Like, what are Terraform modules exactly? Let's say I had turned up an EC2 instance, and as you could see, when I turned up an EC2 instance, I kept everything as same. But only thing that I changed was the names. Let's say the only thing that changed was names because everything is Ubuntu, everything is T2 micro. The Ubuntu ID might be different, but everything is same. Only thing that I changed was name. For both, it's like name. Only to them. For that, I had written it two times. Let's say both are EC2 resources, and for that, I had written it twice. So it's actually unnecessary. What do you call? Unnecessary to write twice. If I had like one thing, like one I could write, and only thing that I could change is name. If I could call like only the changes of variable, like wherever the changes are applicable, only there if I could make the changes using a single command, like let's say a single variable kind of thing. Let's say if I give this as a variable, and every time I want to use this block, I would be changing only the variable name and rest stays the same. That is where like Terraform modules help you a bit. It's like the code would be same, only the changes that are required, like we would specify those changes. And one example that I did here was a basic example was Terraform S3 bucket that I gave because EC2 instance, however, we came to know how to do that. Mm. Yes, modules, and this is the bucket, like bucket module, S3 bucket module. We will be using this itself. As you could see in main.tf, I had used AWS S3 bucket, like which is Terraform to call. And main is something, but you could actually change it to name or something as well. Like this doesn't matter. And whatever you call it here, like this is actually a name given to Terraform. So as you could see, this is AWS S3 bucket.main.id, and inputs is the one like which it would wait for it. For our input, it would wait. And for this, like if you don't want even to give this input, you could actually use another thing called, okay, this one we can't change. I'll actually like copy this and I'll show another value called as default. Just like we will add a single line called default so that you don't even have to specify that variable name as well. Let's say if I want to use this module, like this module is like it'll take up the S3 bucket and it'll turn up. And for us to use this module, what we are going to do, we are going to call by using a module name inside our repository. Exactly this. As you could see, bucket name is the variable. So what is this bucket name? Bucket name is a variable input, as you could see. So this is input and variable is bucket name. So we were giving this variable so that like it'll turn up for us. Let's say now, let's use this. So I'm just going to use this module. Once the modules are ready, you could just like call it, call wherever the repo is, or even the Azure or AWS, wherever it is. You could call that repo. And from there, I'm using this like I'm giving bucket name as random bucket name 84993. And here for S3 bucket, you had to remember like S3 bucket towards globe, it must have unique name. If someone had used this name already, I will not be able to use this name. Only thing that you had to remember here for S3 bucket, let's say, because now it is a module and in S3 bucket, so I'm just calling up this like Terraform initialize. As you could see, it's downloading our Git repo. As you could see, it already downloaded, I guess. Yeah, as you could see, .terraform now comes with module, which is not there before S3 bucket. And here is inputs, the same thing which I showed in repo, it downloaded. And here, if you want to use something, like as you could see, because of the extension we installed, it's giving us this. Default is equal to something. Let's say you could even like give like random the same thing instead of specifying there. You could even use this default values inside variables. Now let's turn up S3 bucket using this module. Terraform init, Terraform plan. Okay, now it has like two AWS resources to be up, and yes, and like one S3 bucket. That is why it has three to add. Now let's say Terraform apply. It's calling the module S3 bucket and it's creating these both. Okay, okay, it created S3 bucket as well. Let's verify that. Where's our console? As you could see, random bucket names 84939. It has been created just now, March 20th, 2025. Hmm. Yes, the modules are created, and even I think the instances as well will be created because we had given that in the plan. Both the instances must be created by now. Okay, I think, okay, yes. As you could see, Terraform import instance, and both were created just now. So this is the use of modules. So it's like instead of repeating the resource, you could just repeat. You could take the block and use only the changes required. Let's say if these AWS EC2 instances are inside same VPC, same region, and same everything, only thing that changes is name, or only thing that changes is T2 micro or T3 medium. You could actually even give this as well as a variable in module. And you could call the module, and instead of like writing resource blocks repeatedly, you could just call module block and change the variable. So till here everyone is clear, right, on how to use modules as well.
Yes, sir. Yes,
Yes.
sir.
Yes, okay. I'll just destroy everything now because we don't need anything because it's a demo. I don't want the resources to be running. And as well, like one more thing that as I specified, like these state files and state logs would be actually in remote backends. Like remote backends, mostly S3 bucket would be used. As I said, like there will be like version 1, version 2, version 3, and S3 bucket provides versioning. So that is where in most cases these state files would be inside S3 bucket, and actually which I'll not be explaining here, but I actually specified, which I saw a video. I thought like that would be helpful. So actually you could, this is the remote state backend using S3 bucket and DynamoDB. So you could just click on this link. I think
Hi,
this
I'm
is from
Dana. I'm
CloudChamp. So this actually
a
covered
filmmaker.
that
Come
like
with me to
completely
create an
in this
entire movie
with the
poster
code.
mockup with the newest.
Says, do you want to copy the existing state file to the new and let's start name this.
So he covered everything with the code. So I would recommend you guys to watch this video as well, like once the blog is done. And yes, so I'm done with this part. And also one more thing I wanted to update, like in industries, how it happens was, let's say a new project came into picture. Let's say a new project came into picture, and they want DevOps engineers to work. So what does this happen? First, an architect comes into play, and whatever the project is there, he specifies like what resources to be used, whether the EC2 instance like with this much of capacity, or S3 bucket with this much of capacity, or let's say mm, let's say even or RDS, AWS RDS, which is database, or even S3 bucket, whatever it is, according to the plan, the architect first designs it, and then like once the design is done, like he would be sitting with the FinOps team or even like budgeting team to see whether the whatever he specified, his plan goes according to the like budget or not, whether the resources would be going into the resources or and like in the budget or not. And there is one thing as well in AWS, like to predict, there is like AWS pricing calculator. Let's say if I want to turn up EC2 instance for mm, create an estimate is the one, like what's the region and like where what's the service, you could actually give that service, and whatever the configuration, based on that it will give you an normal cost. This I'm just normal explaining an architect overview. Whatever is there, based on that, even though your resource is not up, it will actually tell how much cost it could happen, like based on that like resources. Once the plan is ready, this would come to DevOps team, and this once it comes to DevOps team, what happens is like we would be checking if we had the present modules or not. Let's say if we had the S3 modules already, we would be reusing these modules. And if we don't have the modules like Terraform modules, let's say RDS module is not there, it will be the job of DevOps engineer to create a RDS module, and from there we would be using the resources. Once we had the modules ready, Terraform modules ready, like the DevOps engineer uses these modules, let's say uses these modules and to provision the resources. So that complete infrastructure would be in the Terraform control. Till here, everyone is clear, like why Terraform is used, how modules are prepared, and everything.
Yes, sir.
Yes, I think yes, I'm done with this Terraform session. Let me stop the recording. One.
It's like an inheritance, right,
What do you mean
bro?
inheritance?